In the second module, on collection and storage, we will look at 4 different technologies which are based on double pits or double vaults. I will explain why it can make sense to install 2 pits and use them alternatingly, and in which situation those 4 technologies are most appropriate. Like everything in life, these technologies also have their advantages and disadvantages. You will learn about them in the next few minutes. Let's start with something that we are familiar with already. The Ventilated Improved Pit, or VIP. What you can see here is basically the same as the single VIP we already know, just with the second pit added next to it. That's why we call this technology the double VIP. Its use is very similar to the single VIP, but when one pit is full, it is not immediately emptied. Rather, the full pit is closed and the superstructure moved to the other one. While the second pit fills, the content of the first one is allowed to rest, drain and naturally decompose, until both pits are full. Only then the first pit is emptied and used again. This cycle can go on indefinitely. Each pit should be designed to accommodate the excreta of 1 to 2 years. During that time, the material in the resting pit becomes partially sanitized and humus-like. We therefore call it pit humus. The humus is a solid product which cannot be pumped and needs to be excavated manually using a shovel. The side walls of the pits can have openings for better infiltration. But the middle separating wall should be waterproof to avoid re-wetting of the resting material. Instead of being moved from one pit to the other, the superstructure may also extend over both pits, as the one shown in this photo. In this example from Mauritania, the superstructure is relatively big because there is also a bathing place in the middle, which is connected to a separate soak pit for the grey water. The picture below shows the 2 access covers for emptying. An advantage of the double VIP is that the pits are permanent and designed for constant operation. With proper maintenance, double pits can have an indefinite service life. Emptying is easier and safer than fecal sludge, because the resulting pit humus is solid, much less offensive, and has a significantly reduced pathogen content. The product may even be used to improve the water and nutrient retaining properties of agricultural soils. As in VIPs, the contamination of groundwater resources is still possible with this technology, and double VIPs are not suitable for rocky ground or areas that are prone to flooding. Because of the product being solid, manual emptying is required. This can be done by the users themselves, which reduces the operating costs and does not require accessibility by vacuum trucks. However, the upfront investment costs for double pits are obviously higher than for single pits. The so-called Fossa Alterna is very similar to the double VIP. Compared to the double VIP, however, which is basically just designed to collect, store, and partially treat excreta, the Fossa Alterna is actually designed to make higher quality, earth-like product that can be used as a valuable soil conditioner. This is achieved by adding soil, ash or leaves as cover material after each defecation, which absorbs the liquids inside the pit and increases the pore space, allowing for aerobic conditions. The cover material also reduces smells and introduces a variety of microorganisms which help in the degradation process. The pits are dug to a maximum depth of 1.5 meters and therefore often do not require a lining on the entire side walls, allowing for soil organisms to enter and do their job. Like in the double VIP, the full pit degrades while the second pit is filling, which ideally should take 1 year. Because of the added carbon-rich bulking material, the degradation process is accelerated and the content is ready for excavation and use much faster than in a double VIP. Grey water should not be added because it fills the pore spaces and deprives the aerobic bacteria of the oxygen that is required for degradation. The advantages and disadvantages of the Fossa Alterna are slightly different to the ones of the WVAP. Emptying is still done manually using a shovel, but may be even easier because of the cover material, which gives the humus a less compact, more aerated form. Important to note is that soil, ash or leaves should be constantly available to generate the desired nutrient-rich, compost-like product. Separate solid waste and greywater management are crucial to ensure a high-quality product. Twin pits for pore flush, sometimes called double leach pits, are designed to receive black water as input and possibly also greywater. As you can see on the drawing, the pore flush toilet is used as user interface and connected to one of the pits by a pipe. The other pit is properly sealed, for example using cement and bricks. Alternatively, it is also possible to use a single straight pipe fixed with light mortar and covered with earth. The black water is collected in the pit and allows to slowly infiltrate into the surrounding soil. As liquid leaches from the pit and migrates through the unsaturated soil matrix, pathogenic germs are sorbed onto the soil surface. In this way, pathogens can be removed prior to contact with groundwater. Like in the previous technologies, when the pit becomes full, it is closed and allowed to rest before being emptied. As this is a water-based wet technology, the full pits require a longer retention time of 2 years to degrade the material. Over time, the content is sufficiently dewatered and can be safely excavated in the form of pit humus, again manually with a shovel. It is recommended that the twin pits be constructed 1 meter apart from each other to minimize cross-contamination between the maturing pit and the one in use. Water within the pit can impact its stability. Therefore, the full depth of the pit walls should be lined to prevent collapse. As you can see in the drawing on the right, numerous openings in the pit lining facilitate the leaching. Twin pits also have a few specific advantages and disadvantages. Compared to the previous options, flies and odors are further reduced due to the use of the pore flush latrine. Because this is a water-based technology, the soil must have a good infiltration capacity. Clay, tightly packed or rocky soils are not appropriate. This technology is not suitable for areas with a high groundwater table or where there is frequent flooding. There is a risk of groundwater pollution when pits are located in areas with a high or variable water table. As a rule of thumb, it can be recommended to have a minimum horizontal distance of 30 meters between the pits and the water source to limit exposing the water source to microbial contamination. Dehydration vaults are watertight alternating chambers that are usually built above the ground to collect, store, and dry feces. One chamber is in use, while the other one dehydrates. When feces are not mixed with urine and other liquids, they dry quickly. In the absence of moisture, organisms cannot grow, pathogens are destroyed, and smells minimized. This technology requires the use of the UDDT as a user interface. Urine is diverted, flows through a hose or pipe, and is collected in a storage tank. What enters the dehydration vaults is only feces, and possibly dry cleansing materials. To prevent flies, minimize odors, and encourage a drying, a small amount of ash, lime, dry soil, or sawdust should be used to cover feces after each use. Ash and lime additionally raise the pH, which causes pathogens to die off. A vent pipe is required to remove humidity from the vaults and control flies and odors. The World Health Organization recommends a minimum storage time of 6 months if ash or lime are used as cover material. Otherwise, the storage should be 1 to 2 years, depending on the climate. Each vault is therefore sized to accommodate at least 6 months of feces accumulation. After the recommended storage time, the pathogens are significantly reduced and it is easy and safe to remove the dried material from the chamber using a shovel. The dehydrated feces can then be used as soil conditioner and the vault put back into service. As long as no liquids enter the chambers, this technology should be a comfortable and odor-free solution. It is therefore possible to build dehydration vaults attached to the house as it can be seen in this photo, or even integrated into the house as shown in this drawing. Dehydration vaults are especially appropriate for water-scarce and rocky areas or where the groundwater table is high. They are also suitable in areas that are frequently flooded because they are built to be watertight. Dehydration vaults can be a clean and easy to use technology. It is crucial, however, that the users are well trained to understand how the technology works and appreciate its benefits. In this module, we looked at 4 technologies which all have in common that they use storage and naturally occurring dewatering and degradation processes to produce a material that is safer and more easy to handle than fecal sludge. The products from these technologies can even be used as soil conditioners. Due to the material being solid, it is not possible to mechanically empty it using a pump. It needs to be dug out manually. This may be seen as a disadvantage, but also as an advantage, especially in areas where mechanical emptying is expensive or impossible due to difficult access. All the double pit technologies shown are permanent and can be constantly used if well maintained. Therefore, they are particularly suited to peri-urban or urban areas where it is not possible to dig a new pit when the old one is full. On the other hand, the potential risk to groundwater sources due to leaching limit the applicability of these double pit technologies in urban areas. In the next module, we are going to look at anaerobic technologies for collection and storage.